Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about the 7 best tricks to understand general tendency of periodic properties. This topic is belongs to 11th class, first PUC students. Third lesson, periodic classification of elements. Here I am going to discuss about the periodic properties, students. Okay, Namma. So total 7 properties: atomic radius, ionization energy, electron affinity, electronegativity, electropositivity, metallic property, non-metallic property. These all periodic properties, how changes in the periods and groups. Now I am going to discuss, students. Okay, Namma. After this after this topic, students, you will get the clear idea on these periodic properties, Nana. Okay, now you can easily understand, you can easily answer any type of bit on based on these 7 periodic properties. Okay, students, now first I'm going to discuss about atomic radius. Okay, atomic radius. First property, students, atomic radius. This is the trick number 1. Okay, this is the trick number 1. So here in the trick number 1, we are going to discuss about atomic radius, students. What is atomic radius? Atomic size or atomic radii is nothing but the distance between the nucleus and the outermost shell of an atom. Okay, now so that is calling us, that is the atomic radius. So we know that atomic radius, Nana, from left to right in periods. In periods, how it is changes, students? In periods, in groups. Okay, in periods and in groups. In periods, how it is changes, students? Atomic size. In periods, atomic size is decreases, students. Okay, now from left to right, from left to right, atomic size decreases. Clear? Atomic size decreases. In groups, students, from top to bottom, atomic size increases, students, because here in the periods the differentiating electron enter into the same outermost shell, but in the groups the differentiating electron in periods the differentiating electron enter into the same outermost shell, students, from left to right. So that's why atomic size is decreases. Coming to the group, students, from top to bottom the number of shells increases, students. Are you clear? Whenever number of shells increasing, then automatically atomic size also atomic size increases, students. Clear? So that's why from top to bottom atomic size increases, from left to right atomic size decreases, students. Clear this one? Atomic size decreases means what, students? Big to small. Okay, now just I will take the diagram. Big to small, left to right decreases, na? So that's why big to, this is, for example, this is the big size atom, this is the smaller size atom. Okay, smaller size atom. So big to small, that is nothing but decreases, students. Here from here to here, left to right decreases. Here from top to bottom atomic size is increases. Top to bottom increases means small to big. Correct? So here I am taking small size atom, and here this is the bigger size atom. Clear this one? So this is the nucleus, this is the nucleus. Okay, now here see, students, here this is the nucleus, this is the, suppose this is the outermost shell. Here here electron is there, suppose valence electron. Here also electron is there, here electron is there, here electron is there. Okay, now see, students, here this one from nucleus to outermost shell, here nuclear this distance, this is atomic size, na? So atomic size is here more. Okay, now the distance between the nucleus and the valence electron distance is more. Here distance is very less. Correct? Distance is less. So whenever distance is more, automatically nuclear attractions are more on the valence electrons. Here distance is less, so that's why nuclear attractions are very less, on very weak on the valence electrons. Are you clear? Whenever distance is more between the nucleus and the valence electrons, distance more means nuclear attractions are less. Are you clear? So here nuclear attractions are nuclear attractions here less. Are you understanding? Here nuclear attractions less. In this case, small size atom, nuclear attractions are more. Understood, Nana? Nuclear attractions more, amma. Okay, now because here distance between the nucleus and the valence electron, it is less distance is there, so that's why nuclear attractions are more. Okay, now in this case here also same thing, from here to here nuclear distance, here distance is less between the nucleus and the valence electron, so that's why what we can say, students, nuclear attractions are more. Clear? In this case nuclear attractions are more. Nuclear attractions more. Now in the case of bigger size atom, here distance, what happens, students? Here distance is more between the nucleus and the electron, valence electron, so that's why here nuclear attractions are less. Are you clear? Nuclear attractions less. Just you remember this point, students, you can easily understand any type of periodic properties. Okay, now so here from left to right atomic size decreases because the differentiating electron enter into the same outermost shell. Here in groups from top to bottom atomic size increases because number of shells increases from top to bottom, so that's why size increases, students. Just atomic size decreases means big to small. Okay, now left to right, this is top to bottom, atomic size is increases here. Okay, understood, students? Nuclear attractions are more, here less, here more, here less. Okay, just you remember this in this way, Nana, you can understand the remaining properties. Okay, so first second property, Nana, this is the trick number 1. Okay, trick number 1 completed, students. So just you remember this one. Now trick number 2, what is ionization energy? Now see here, trick number 2, students. In trick number 2, we are going to discuss ionization energy. Ionization energy. Now tell me, students, ionization energy is nothing but energy is required to remove the valence electron from the outermost shell of an atom. Okay, now so that is nothing but ionization energy. That means to remove the valence electron, how much energy is required? That is nothing but ionization energy, students. Okay, now see, Nana, here ionization energy. Suppose this is the valence electron. Okay, here I am taking in periods. Okay, in periods. Now tell me, students, here in periods atomic size, what happened? Atomic size decreases. Correct? Atomic size decreases, so big to small. Here nuclear attractions, what happens, students? Here nuclear attractions are less. Nuclear attractions less, so that's it. Here nuclear attractions are very less on the valence electron, so that's why we can easily remove the valence electron. Okay, now by the supply of little energy, so that's why in this case ionization energy is less. Are you understanding? Because in the periods nuclear attractions, what will happen, students? Atomic size, in periods atomic size, what will happen? Atomic size decreases. Atomic size decreases means big to small. For example, this is big, this is small atom. Okay, now see, students, left to right in periods atomic size decreases. So here nuclear, this is the valence electron, this is the valence electron. Here from here to here attractions are nuclear attractions. What will happen, students? Here nuclear attractions on valence electrons. Okay, nuclear attractions on valence electrons, here attractions are less. Are you understanding? Nuclear attractions on valence electrons less, because here distance is more, so less. So that's why we can easily remove the electron. So in this case ionization energy is less. Are you understanding, students? Ionization energy less. Now here in this case, students, here nuclear attractions are more because here distance is very less, so that's why nuclear attractions, what happened? Nuclear attractions on valence electrons more. Whenever nuclear attractions are more, the nucleus is not ready to lose electrons, so that's why we have to supply more energy to the electron to remove the electron from the outermost shell. Are you understanding? We have to supply more energy, so that's why ionization energy in this case more. Clear? Here ionization energy less, here more. Left to right, what happens, students? Less, small to big. that is nothing but increases. Are you understanding? So in periods, ionization energy, what will happen students? Ionization energy increases. Clear? Increases students. Okay, in periods completed. Now we are going to discuss in groups. What about in groups students? We know that from top to bottom atomic size increases students, because number of shells increases, atomic size increases. Okay, now top to bottom what is happening? Atomic size increases. That means small to big kada, atomic size what will happen? Atomic size increases in groups from top to bottom. Are you understanding? In periods means left to right, groups means top to bottom. Are you clear? Top to bottom. So atomic size increases students. Increases means what? Small to big. Are you understanding? Small to, for example, this is small atom, this one is big atom. So from here to here, you tell me students, here electron is there, here valence electron is there. Here nuclear attractions, what happened? Nuclear attractions on valence electrons here more, nuclear attractions are more. In this case nuclear attractions are less. Are you understanding? Nuclear attractions less, so that's why here attractions are more, so that's it is not ready to lose electron. Here we have to supply more energy to remove the valence electron, so that's why here ionization energy is more. In this case ionization energy is less because attractions less, so that's why we can easily remove the electron. Very less energy is enough, ionization energy is less. Now here more, here less. Okay, now top to bottom what happened? It is big, it is small. Big to small is nothing but decreases. Are you understanding? So finally what we can say? Ionization energy here top to bottom what happens students? Decreases. Clear this one? Decreases. Okay, decreases students. So this is the trick number 2. Now we are going to discuss about the trick number 3, that is electron affinity. Now see students, electron affinity, trick number 3. Trick number 3. What is trick number 3 students? Electron affinity. Electron affinity. What is this electron affinity students? Electron affinity is nothing but energy is released when electron is added to the outermost shell of an atom. Whenever electron is added to the outermost shell of an atom, energy is released. Okay, now energy is released students. So that is nothing but electron affinity. Are you clear? In the ionization energy, energy is required to remove the electron. Are you clear? To remove the electron, how much energy is required? That is ionization energy. Okay, understood amma? So electron affinity, so just you remember students, ionization energy is nothing but what students? Energy is required to remove the electron. Okay na, energy is required to remove the electron from the outermost shell. Okay, from the outermost shell. Clear this one? Okay, just a small definition. Now we are going to discuss the electron affinity. What is the definition students? Electron affinity, energy is released when electron is added to the outermost shell of an atom. Okay, now energy is released, energy is released when an electron is added to the outermost shell of an atom, is added to the outermost shell, okay, of an atom. Clear this one? Just definition students, energy is released when electron is added to the outermost shell of an atom. This is nothing but electron affinity. So okay, in periods, this is a trick number 3. In periods, how it is changes? In periods and in groups. In periods means left to right. What happens students in periods? Left to right, atomic size decreases, correct? Here left to here groups nana, top to bottom atomic size increases. Clear? Increases. Here decreases means what students? Big to small. So this is the bigger size atom, this one is smaller size atom. Okay, now here see students, here this is small size, this is bigger size atom. From left to right what happens students? Here atomic size decreases. What about electron affinity? Electron affinity is nothing but energy is released when electron is added. Now see students, here nuclear attractions, what happened? Nuclear attractions are here less, here nuclear attractions more. Are you understanding? On the valence shell. So that's why here what is happening, whenever giving electron to the, whenever adding electron to the outermost shell, students, in the bigger size atom, here nuclear attractions already less, nuclear attractions are already less on the valence electrons because distance is more. Whenever electron is given to the outermost shell, then nucleus is not ready to accept this electron, students. So that's the addition of electron is very difficult in the size of, in the case of bigger size atoms, students. In the case of smaller size atoms, here addition of electron is easy, Nana. Are you understanding? In this is smaller size atom because nuclear attractions are more. Whenever electron is given to the outermost shell, this nucleus is nearer to the outermost shell, so that's why it is ready to accept this electron. Are you clear? Now in this case, electron affinity is more, students. To take this electron, this nucleus is ready to lose more energy, students. That means electron affinity is more, because here whenever giving electron to the outermost shell, here in the outermost shell electrons are there, these electrons are having the negative charge. Whenever electron is added to the outermost shell, in between the same charges, repulsions are taking place. Okay now, so to overcome that energy, here to overcome that energy, overcome that repulsions, this nucleus is using more energy, it is losing more energy to accept this electron into the outermost shell, students. So that's why electron affinity is more. Here in this case electron affinity is less, students, because here addition of electron is it is difficult because nuclear attractions it is less. That's why here we have to supply energy to keep the electron into the outermost shell, students. Are you understanding? We have to supply energy. Are you clear? So just two important points you remember, students. Here during addition of an electron, if energy is released, okay, if energy is released, if energy is released when an electron is added, when electron is added, if energy is added to the outermost shell of an atom, students, when electron is added, if energy is released, that is calling as negative, that is calling as negative electron affinity. Okay, now negative electron affinity, students. Next one, if energy is absorbed, if energy is absorbed when an electron is added, if energy is absorbed when electron is added, students, so that is calling as positive electron affinity. You remember these 2 points, students. Are you clear? Remember these 2 points. Okay now, so here nuclear attractions are less, so that whenever electron is given to the added to the outermost shell, this nucleus is not ready to accept this electron because attractions less. So that's why we have to supply more energy to keep this electron into the outermost shell, students. We have to supply more energy to the electron. So that is nothing but here we are supplying, that means energy is absorbed in this case when electron is added. So here we have to supply energy to keep this electron into the outermost shell. So that's why here energy is absorbed, that is nothing but positive electron affinity is more, negative electron affinity is less. In this case, students, here nuclear attractions are more. Okay now, so that's why whenever electron is given to the outermost shell, the nucleus is ready to accept. Okay now, ready to accept, so that's why electron affinity is more. Before that, here electronic repulsions will be there. To overcome that repulsions, this nucleus is ready to lose more energy to take this electron, to accept that electron. So that's why here electron affinity is more. So here it is less, here it is more. So from left to it, that means it is small, it is big. That means what we can say, left to right, it is increases. So electron affinity increases in periods. Okay, electron affinity, what is happening, students? Electron affinity in periods increases. Clear this one, electron affinity increases. Now coming to the group students, top to bottom atomic size decreases. Now atomic size decreases means what? Atomic size increases means what, students? Small to big. So this is a small size atom, this is a bigger size atom. Okay, bigger size atom. Okay, now we are giving electron to the outermost shell, we are adding electron to the outermost shell. Now see students, here nucleus is very nearer to the valence shell. Okay, now distance is very less, so that's why whenever electron is added to the outermost shell, nucleus is ready to accept this electron, so that's why here electron affinity is more. Now in this case nuclear attractions are less, so that's why addition of electron is difficult, so that's why here we have to supply more energy to the electron to keep the electron into the outermost shell, so that's why here electron affinity is less. Are you understanding? That means very less energy it is releasing. Here to take this electron, nucleus is losing very less energy. To take this electron, more energy it is releasing, because here electrons repulsions are taking place. Are you clear? So that's why here it is more, it is less. So that means top to bottom what is happening, students? This is big, this is small. Big to small is nothing but decreases. Are you clear? So that's why electron affinity it is decreases from top to bottom. Are you clear, students? It is decreases. Here there are exceptional cases, students. What is that? Exceptional cases in the case of fourth A group. For example, I am taking the fourth A group elements. So what about the fourth A group elements? Now this is fourth A group. Okay, now see now fourth A group. What are the fourth A group elements? Carbon, silicon, germanium, tin, lead. Correct? So these are the fourth A group elements. So that means here fourth A group elements from top to bottom, what is happened? Electron affinity should be decreases. Decreases na? Decreases means here it is decrease. That means carbon should have the more electron affinity. Correct or not? It is a smaller size atom, so that's why it should have the more electron affinity. So but in this case here what is happening, students? It is not showing the more electron affinity, but when compared to silicon, students, carbon is showing the less electron affinity, students, because of its smaller size. Are you understanding? Because of its smaller size, because carbon size is very small. Okay, now see students, carbon size is very small. Okay, size is very small, so that's why what is happening, students, whenever size is small, okay, size is small, what is happening, students? See here, this atom size is small, carbon atomic number is 6, 1s2, 2s2, 2p2. Correct? Electronic configuration, that means 2 shells are there, 1 2. Okay, 1 2, 2 shells are there. Now see here, students, here in whenever size is small, between the shells, first shell and second shell, the distance also very less. Are you understanding? Distance is less. Clear this one. The gap is less. So whenever gap is less, here the first shell electrons there, second shell also electrons there, 2 plus 2, 4 electrons there, first shell 2 electrons are there, here 2 electrons, here 4 electrons are there. Between them, repulsions are taking place. Interelectronic repulsions are more. Between them, interelectronic repulsions are more, because very small size atom, whenever size is very small, what happened in between the shells also distance is less. Whenever distance is less, interelectronic repulsions are more. Are you understanding? Interelectronic repulsions are more. Whenever giving electron to the outermost shell, it is ready to accept this electron? No, because already they are fighting. Correct? Repulsions are there. So that's why these electrons are pushes back this electron. They will not allow this electron. So that's why here we have to supply energy, students. That means whenever energy is supplying, that means energy is absorbed during the addition of an electron, we'll call it as positive electron affinity. That means here in this case positive electron affinity is more, negative electron affinity is less. Are you understanding? Negative electron affinity is less. Negative electron affinity is nothing but energy is releasing. So generally electron affinity is calling us negative electron affinity. Are you clear? Negative electron affinity only electron affinity. Are you understanding, students? So that's why, because of this reason, students, very small size atoms, here what happened? Interelectronic repulsions are more. Interelectronic repulsions are more. Clear this one. Inter-electronic repulsions more. So that's why what is happening, students, here? It is having the electron affinity. Electron affinity is small. Are you clear? Electron affinity is less. So that's why what is the correct order, students? Here you have to take first silicon element. So that's why what is the correct order? See here, correct order is silicon, carbon, germanium, tin, lead. Okay, first silicon will come, next carbon will come. So which is having more electron affinity? Silicon. This one. This is the correct order, students. It is the fourth A group. As it is fifth A group also. See, students, fifth A group. What about the fifth A group, students? Fifth A group elements. What are the fifth A group elements? Nitrogen, phosphorus, arsenic, antimony, bismuth. Now in this case, nitrogen, phosphorus, arsenic, antimony, bismuth. Again same thing. Nitrogen smaller size atom. So that's why in between the shells also gap is very less. So that's why inter-electronic repulsions are more. Okay, whenever giving electron, they are not ready to accept that electron. So that's why, okay, nucleus is not ready to accept that electron. We have to supply more energy to keep the electron into the valence shell. So that's why here electron affinity is less. That means positive electron affinity is more, negative electron affinity is less. Clear this one? Negative electron affinity is less. So that's why here which is having more electron affinity? Phosphorus greater than nitrogen, greater than arsenic, greater than antimony, greater than bismuth. You have to remember this one. Very, very important, students. Fifth A group. Now coming to the sixth A group. 6A group. What about 6A group, students? Oxygen family. Okay, now what are the oxygen family, students? Oxygen, sulfur, selenium, tellurium, polonium. Now see, in this case also oxygen smaller size atom. So that's why in between the shells, in between the two shells, what is happening? Inter-electronic repulsions are more. So that's why electron affinity is less than sulfur. So that's why here what we have to write, students? Correct order is what? Sulfur greater than oxygen, greater than selenium, tellurium, polonium. Clear this one? So this is the correct order, students. Now coming to the fifth A group. This is fifth, sixth A group over. Now seventh A group elements. What about seventh A group elements, students? What about seventh A group elements? Fluorine, chlorine, bromine, iodine. Okay, now and astatine also. Okay, now fluorine, chlorine, and bromine, iodine, astatine. Okay, now see, students, here which is having the more electron affinity? Same order, students. Here what we followed as it is, you have to write. Chlorine is the, now fluorine is having the very small size atom. So that's why in between the shells gap is less, inter-electronic repulsions are more. So that's why electron affinity is less. So that's why chlorine, what is the correct order, students? Chlorine greater than, fluorine greater than, bromine greater than, iodine. Are you understanding, students? Chlorine order is first. Okay, this understood, Amma. This is nothing but chlorine, fluorine, bromine, iodine. Clear this one? Chlorine, fluorine, bromine, iodine. Till here it is enough, students. Okay, now. And here also polonium is a radioactive element. Now. So till here it is enough, Nana. Till here only you take this order. Okay. Clear? Right. So here also up to iodine you take. Okay. Right. So chlorine, fluorine, bromine, iodine. Okay, understood, students. So this is the electron affinity order, Nana, from top to bottom in fourth A, fifth A, sixth A, seventh A group. This is the trick number 3. Now trick number 4. What is the trick number 4, students? Trick number 4. What is the trick number 4? What is the fourth property, students? Fourth periodic property, electronegativity. What about electronegativity, students? What is electronegativity here? Just you remember, students, electronegativity is nothing but gain of electrons. Okay, now by gain of electrons, the electrons will become, electronegativity is nothing but, okay, now the elements by gain of electrons, they becomes electronegative in nature. Correct? Gain of electrons. Yes, gain of, just you remember this simple definition, gain of electrons. Okay, now in periods, in period students, left to right, atomic size decreases. Are you understanding? Decreases means big to small. This is big, this is small. Now here nuclear attractions are less, nuclear attractions are more. Are you understanding? So here electronegativity kada, electronegativity is nothing but gain of electrons. Whenever giving electron, it is ready to accept. Okay, tell me students, here nuclear attractions less, so that's why when this electron, it is not ready to accept because attractions less. So that's why here electronegativity is more, electronegativity is less. Are you understanding? It is nuclear attractions are less. Are you clear? Attractions less, so that's why it is ready gain of electrons. It is ready to gain of electrons? No, it is not ready to gain of electrons because attractions less, distance is more, electronegativity is less. Here nuclear attractions are more. Whenever giving electron, it is ready to accept, so that's why ready to gain of electrons, so that's why it is calling as electronegativity is more. So small to big is nothing but electronegativity. What happened? Left to right, electronegativity, it is small, it is big, that means increases. Understood students? Clear? Increases. Okay, now coming to the groups. What about in groups, Nana? In groups, top to bottom, atomic size increases. Okay, atomic size increases is nothing but, increases means small to, this is small size atom, this is bigger size atom. Okay, bigger size atom. Now tell me students, here nuclear attractions are more. Whenever giving electron, it is ready to accept, it is ready to accept means, okay, now this is nuclear attractions, electronegativity more. Here nuclear attractions are, whenever giving electron, it is ready to, that means they are ready to gain off electrons, giving, it is ready to accept these electrons. Yes, it is nuclear attractions are here less. Nuclear attractions less means it is ready to, it is not ready to accept this electron, electronegativity less. So that's why here big go, here less, big go small, that means here what we can say, decreases. Okay, electronegativity top to bottom decreases. Understood this one? Electronegativity decreases. Over. Next one students, trick number 5, electropositivity. Now see here, electropositivity. Trick number 5, electropositivity. What is electropositivity students? They are ready to lose electrons. What is the main character? Ready to lose the electrons. Clear? Ready to lose electrons. Just you remember this small shortcut students, enough. Ready to lose electrons. Now tell me in periods what is happening? In periods, left to right, atomic size decreases. In groups, okay, top to bottom, atomic size increases. Okay, increases. Here decreases na, decreases means what? Big to small, big to small. Okay, atomic size decreases means here nuclear attractions, nuclear attractions less, here nuclear attractions more. Okay, now it is here nuclear attractions are less means it is ready to lose electrons. What is this electropositivity? Ready to lose electrons. It is ready to lose electron. Yes, attractions less kada, so that's why it is ready to lose electron. Are you clear? So that's why electropositivity more. Now in this case nuclear attractions are more on valence electrons. It is ready to lose electron? No, it is ready to, it is strongly bounding this electron. Okay, it is not ready to lose electron, so that's why electropositivity is less. Are you clear? So that means big to small, what is happening to left to right? Decreases. Are you clear? So electropositivity left to right, what happens students? Decreases. Clear? Understood, Emma? Electropositivity left to right decreases. Now coming to here groups. Top to bottom, atomic size increases. Atomic size increases. Increases means what students? Small atom to bigger size atom. Okay. Now here nuclear attractions, what is happening? Nuclear attractions on valence electrons Now tell me students, nuclear attractions are more. More means it is ready to lose electron? No. That means electropositivity less. Are you clear? Here nuclear attractions less because distance is more. Attractions less. Attractions less, then it is ready to lose electron. Electropositivity more. So here less, here more. Electropositivity. So that's say from top to bottom what happened? Electropositivity, top to bottom electropositivity, small big increases. Are you understanding? Clear? Increases. Electropositivity increases. Understood students? Now trick number 6. What is the trick number 6? Metallic character. Metallic property. What is metallic property? They are ready to lose electrons. Correct? Metallic property is nothing but ready to lose electrons. Ready to lose electrons. Now tell me students, in periods what happened? In periods left to right, atomic size decreases. Here in groups, so top to bottom atomic size increases. Clear? Atomic size increases. Decreases means big to small. Atomic size big to small. Big to small means here what happened? Nuclear attractions. Here nuclear attractions less. Here nuclear attractions more. Okay. Then here what is metallic property? Ready to lose electron. It is ready to lose electron because attractions less. So that's it is ready to lose electron. So that's a metallic property. What happened? Metallic property. Here it is ready to lose electron kada. It is more. Here in this case metallic property here attractions are more. That's it is not ready to lose electron. So that's a metallic property decreases. Okay. That means here increase, here decrease. That means what we can say finally? What we can say students? Decreases. Left to right metallic property left to right decreases. Clear? Decreases. Now coming to the groups, top to bottom atomic size increases. Increases means small to big. Small to big. Clear? Small to big. Here nuclear attractions what happened? Nuclear attractions are more. Nuclear attractions here less. Attractions more. It is ready to lose electron? No. So that's why metallic property less. Here nuclear attractions are less. That's it is ready to lose electron. Nuclear attractions on valence electrons less. So that's it is ready to lose electron. That means metallic property more. So here small, here more. That means top to bottom increases. Are you clear? So metallic property students, not melting point. Metallic property top to bottom increases. Clear this one? It is increases. Understood? Now trick number 7. What is the trick number 7? Non-metallic property. Non-metallic property. What about non-metallic property students? Non-metallic property again in periods left to right atomic size decreases. In groups top to bottom atomic size increases. Now see students, decreases means big to small. Okay. Now here nuclear attractions less. Here nuclear attractions more. Here non-metallic property is nothing but ready to gain the electrons. Are you clear? Ready to gain electrons. Now tell me here attractions are less. Attractions less means it is not ready to gain the electron. So that's why here non-metallic property less. Here attractions are more. So that's why it is ready to gain the electron. Are you clear? It is ready to gain the electron. So that's why here what we can say, non-metallic property more. Here small, here big. So what we can say finally, non-metallic property left to right increases. Clear this one? Increases. Okay. Now here see students, top to bottom atomic size increases. Increases means small to big. Okay. Small to big. Here what about nuclear attractions? nuclear attractions are more, then it is ready to gain the electron attractions more. So here whenever electron giving, it is ready to gain. Yes, it is ready to gain because nuclear attractions are more on the valence electron, so that's why it is ready to gain. That's why arrow non-metallic property more. Now in this case nuclear attractions less, it is ready to gain the electron. No, so that means non-metallic property less. So here what we can say, students, top to bottom, non-metallic property top to bottom decreases, clear this one? Understood, students? So these are the 7 tricks, all the properties we discussed, students. So finally, just to remember all the 7 properties, I will tell you in one table, students. Then you can easily remember the table. So if suppose you are not following this all the tricks, if you are unable to follow, at least you practice this table, then you can easily answer any type of bit. Okay, so here, students, periodic property, first column, periodic property. Next, second column, in periods. Next, in groups. Okay, here only I will discuss you 7 properties, students. So first property is atomic size. What about atomic size, students? In periods decreases, here in groups increases, over. Okay, next, second point, second arrow, ionization energy. Ionization energy increases, here decreases. Third one, electron affinity. In periods, students, increases, in groups decreases. Fourth property, electronegativity, correct? Electronegativity. Fifth one, electropositivity. Sixth one, metallic property. Seventh one, non-metallic property. Are you clear? All properties we discussed. So first, electronegativity. Now coming to here, electronegativity, what happens, students? Increases, here decreases. Electropositivity, what will happen? Electropositivity decreases, here increases. Next, this one, metallic property, what happened? Decreases, here increases. Clear? And last, non-metallic property, what happened? Non-metallic property increases, here decreases. Clear, students? Just you practice this table, you can easily answer any type of question, students. If you remember this table, it is enough, Nana. So I hope you understood this video. Okay, if you like this video, students, please like, share, comment and subscribe my channel, students. Thank you very much, students.